So here it is, the fish feeder. So it's mostly 3D printed parts. Plastic container from eBay. So there's a star-shaped drive in there attached to the stepper motor. So that slides in there. There's a retaining collar there which stops it from falling out. And then here's the electronics. Plug it into a power bank, USB socket. Power bank needs turning on. That's better. Okay. Let's get it under the camera. So at the moment it needs software because all I can do is to see the time and feed now. Ollie can't get out. Let's watch it go around. Here it goes. It deposits a measured dose of food. Cat's interested. Ollie, get out of it. She likes the fish food if nothing else. There we go. So all I need to do now is to redesign slightly the feeder mechanism so that this bit of electronics will fit somehow into the back of there. I think I need to print a slightly larger recess underneath the stepper motor. In fact, probably bring it out in line with the stepper motor, a hollow box, and then that can be mounted inside the hollow box. And you'll notice that 1808 is in fact the current time, approximately. And it stores the time, so when I unplug it, you'll notice that I didn't set the time. When I plug it back in, it'll keep the clock. And I've actually just noticed when I was looking at the data sheets that this enormous CRT 2032 coin cell could actually be replaced with a supercapacitor or a tiny lithium single cell, and the real-time clock actually has a trickle charging circuit for lithium or supercapacitors, so I could actually put a very much smaller one in there just to maintain the time for 2 or 3 weeks if the power goes down. That coin cell will actually keep that clock running for 3 or 4 years actually without any other power. Great, so that's a fairly successful Sunday.